Welcome back, everybody. So now that you've finished taking all of your measurements outside and measuring how many steps and using the compass to figure out your direction, now we're going to come back to the packet and fill out everything we know. So what I'm going to do is I'm going to fill out all of the information that I took when I went outside and did it, and I'll put that on the left-hand side here of the second page under the teacher-led vectors. And I'll show you everything that I'm going to do to finish this project. And then all you have to do is just copy my steps and repeat and do it on your own. All right, so here is basically what we're doing. I started at A, and I walked a certain distance and certain steps to B, and I measured however much that angle was as well. So there is vector AB. And then I walked in a different direction to another point, C. So there's vector AC. And what we're eventually doing is we're going to find the resultant vector by adding these two. And what this would look like visually is be going from A up to C. What is that new vector? And that's what I tried to measure when I was there, just using my eyes. How far is it to get from A all the way to C just by looking? And then I actually walked the distance to find out how long it was. And now I'm going to do it here on this page using just math. But that's the idea. We're taking vector AB, we're taking vector BC, and we're going to add them together to get my final component vector here. All right, let's write down everything that I got when I was outside there. All right, when I started at A and I walked to B, I found out that it took 33 paces to get from A to B. And then, that's not a very good measurement, right? So what I did is I need to find out how long was each step or each pace. So I measured my actual shoe length that I used when I went walking outside, and my shoe length, now not trusting what the actual shoe says, but I used a handy dandy ruler and I measured it, and my shoe length was 11 inches. Okay, well that means that my distance, my actual distance from A to B, now in terms of feet, is going to be basically my 33 times 11 inch per pace. So 33 times 11 gives me 363 inches, but I have to put it in terms of feet. So this would be 30.25. And we get feet by, again, dividing your inches by 12. All right, so that means walking outside, my distance from A to B was basically 30.25 feet. Okay, the compass direction when I was walking, I wrote down that my compass direction was 67 degrees. That was my compass direction from A to B, and I kept it as steady as I could. All right, and then I went from B and I walked over to C, and that I walked 32 steps or 32 paces. All right, then I knew that the length of each pace was 11 inches, so I multiplied my 32 times 11, and I got that my actual distance was 352 inches, which again, divide by 12, was about 29.33 feet. All right, that means this distance up here was about 29.33 feet. All right, and my compass heading. As I was walking from B to C, I know that my compass read 350 degrees. Great. So now what I can do is I can take my vector A to B and my vector B to C and write that into component form. But before I do that, while I was outside, I just used my eyes, starting from A and looking to C. I guessed that it would take me probably about 50 steps or 50 paces to get from A to C. And then that means that would be 50 times 11 inches each would be about 550 inches, which again, divide by 12, would be about 45.83 feet. That was my guess. That was just me using my eyes, no app or anything. I just guessed, I looked, and then direction, again, no app, I just guessed. It was probably about maybe 20 degrees. Knowing where 0 at north was on my original compass, I guessed it was a little bit about 20 degrees. That was just a guess. And then I walked it. And when I walked it, I counted my paces, and it actually took me 52 paces to get there. I was pretty close, which means my distance, if I multiply that by 11, is about 572 inches, which, again, in terms of feet, would be about 47.67 feet. All right, that's the actual distance from me walking it And while I was walking, I checked my compass app and it said that I was walking at about a direction of 25 degrees. Again, that was pretty close. That was a pretty good guess. All right, so those two are done. My estimations, just looking at it, and then my actual walking on location. And remember, folks, this is the part here that I need you to film. So I want to see you walking through and see how close you were. All right, now I'm going to actually do the real answers using math and using vectors. All right, so why don't we take the vector A to B and put it in component form, and I'll do vector B to C, and then I'll just add them. All right, here is vector AB. Now I'm given magnitude, that was the length, and I'm given my direction. So I can say that is magnitude, which was 30.25 times the cosine, and the bearing there was 67 degrees, comma, magnitude times the sine of 67 degrees. All right, that's my AB vector in component form. I'll put that in the calculator in just a second, but let me do my B to C vector. When I walked from B to C, that was, magnitude was 29.33 feet times the cosine of, my direction angle is 350 degrees, and same thing again, but with sine. All right, there we go. So now to find my resultant vector, I'm basically just going to take those two vectors, put them in the calculator, and let's add them. Okay, when I do that, after doing all that hard work and punch into the calculator, my final component form here from A to C is 40.7, comma, 22.76 or so. All right, so that's my component form of my resultant vector, but I need to find then what's the magnitude of that, and I'll compare it with my actual magnitude that I found, and then I'll find out what is the actual direction of that, and compare that to the direction that I found over here. All right, you know your formulas, Pythag for mag, and when I Pythag for mag, I got that my magnitude, or my length from A to C, was 46.63 feet. Will you look at that? That is 46 over here, 0.63 feet. What did I get actual on location? That's pretty close. That's kind of cool. All right, now let's actually do the direction angle. So that's the tan inverse. And I do the tan inverse. And I'm going to check my quadrant. I think everything works out in the first quadrant, but you should check your quadrants too, folks. My actual direction angle results in 29.21, and that's our tan inverse formula, right? All right, I'll put that in. 29.21 degrees. Well, look at that too. Look how close I was to where it was on location. That's really neat. If you did it right, you should get very, very close to that. And if not, we're going to explore why. So this is what I would do. Now make sure you write down all of my information here too. You don't have to draw the diagram unless you just want it for help. But please do fill in all of my information here on the left side of the sheet. And then all you have to do, folks, is just fill in now your side. You can use your blank space up here to draw your vectors or to put component form for your vectors or wherever you'd like to work. But again, please do remember everything's in terms of feet. So if you were in inches for the shoe size or if you're walking, please make sure you translate everything into feet. Now let's check and see what happens when you are all done. How close are your actual answers to what your guess was when you were on the field? And to also, what was your actual answer when you walked it? Was it close or was it pretty far off? And depending on what that is, that's going to be your answer at your final analysis. So find out how close were those three measurements. Were they pretty close or were they pretty far off? If they were close, why? Why were they close? What made them so close to each other? If they were pretty far off, what do you think happened? Why were they far from each other? So I would say write about 3 to 4 sentences here, folks, explaining your answer to this. And that's all you have to do. And then you're all finished with this project, guys. Sounds good? All right, good luck.